Alright guys, welcome to RC Mojo. If you watched the last video, you may have noticed the Pajero was struggling a bit. The old 55 turn motor was never all that torquey, and I think the last couple of years running haven't really done it any good. It's got so little torque it doesn't even break traction, even on this low grip and very steep surface, while the MCA is happily spinning all 8 of its wheels. Something needs to be done. Right, here's what's currently in a Pajero, a 55 turn 550. Even at the time it was current, it was considered quite weak, running best at higher voltages. I reckon it's a motor probably spec'd for an 18 volt cordless drill, not for running at 7.2 volts. The replacement I have is an RC 4-wheel drive branded 45 turn 540. It should get us some more wheel speed and, more importantly, more torque. The motor isn't anything special, a bog standard can, bushed and with some leads pre-soldered. Not amazing, but it should do just fine in a little scaler. A lot of people get the wrong idea about motor turns and the effect that they have. A general description you often see is the more turns, the greater the torque, but the lower the speed, or RPM. But that's not quite right. I'm going to generalise quite a bit here, but let's have a go. A high turn motor like our 55 turn will have little torque and a low RPM for a given voltage, which sounds like a bad combination, which it is. But the plus side is the motor takes very little power, so the run times border on ridiculously long. A lower turn motor, let's say the good old 27 turn silver can, will have more torque, quite a bit more actually, and a far higher RPM for the same voltage. But to achieve that takes more power, so less runtime. So the 27 turn sounds best, right? Well, now we need to consider the trucks, in particular the gear ratio. Most trucks, like the Axial SCX-10, have a wide range of options, so you can pop on a really small pinion and a large spur gear. This gives you a low gear, like first in a full-size car. The motor has to spin faster to achieve a certain wheel speed. And if you remember, the 27 turn has a higher RPM, and we can use that high RPM and end up with a torque monster. My SCX-10 Land Rover with this exact setup will happily do wheelies from stopped. The 27 turn motor still sounds pretty good at this point, but there's a problem. Some trucks, like the CC-01, have very limited gearing options. Even with the smallest of the pinion options, the CC-01 is still something like driving around in third. This gives us a bit of a problem. The 27 turn motor will still work, but crawling is a bit tricky. There's just too much speed and not enough fine control when driving slowly. We can't just fit a smaller pinion because of the truck design, and this is where the high turn motors come in. The lower torque makes them feel much smoother when crawling, and the lower top speed keeps things nice and scale. Now, the ideal fix for the CC-01 is a gear reduction unit between the motor and the gearbox. We can have a much lower turn motor and gear it just like the SCX-10, the best of everything. Unfortunately, that requires quite a few modifications, but it would make the truck so much nicer to drive. Right, that's the non-technical description. There are charts with brush motor efficiency, torque and RPM curves, information about gear ratios, and the effects to be found all over the internet, if you really want to get more technical. Oh, and you may have spotted a metal sleeve around the new motor. The gearbox lid on my truck is a little bit warped. Without some sort of sleeve, the motor is a loose fit. Really need to get a new lid. The sleeve is meant to slightly change the magnetic field of the magnets, increasing torque, but I've never actually noticed the difference. If the sleeve is a bit too thick, I'll use something else. On a non-warped truck, of course, the RC 4-wheel drive motor will drop straight in. Well, the truck runs, no nasty sounds, so we're good to go. Best way to show the difference, I think, is to pop back to the hill we had trouble with the other week. The ground was quite dry and loose, so you can see when the truck stops the wheels are still turning. This was at full throttle. You can see just how low the RPM of the motor must be. Here the truck has found some grip and got itself stuck. It's being rocked, but it's not got the torque to break traction. Meanwhile, the MC8 with its 35 turn motor and low gear is quite happily spinning all 8 of its wheels. At this stage the Pajero was at full throttle just to stop it rolling back down the hill, completely useless. We had to hook up the MC8 and pull it the rest of the way. Now we have the 45 turn motor in. It's rained quite a bit, so the ground isn't as loose. Actually, it's quite tacky. It's quite clear there's a bit more torque, power to turn the wheels, and the higher RPM. Further up, where there's some loose bits of chalk, the Pajero is still very sprightly. A much better motor for this model, I think. It still didn't get over the top though, but that's just the lack of ground clearance. There we go then. But one more thing before I go, not all motors are created equal. There are weak 55 turn motors, like the old axle snapper, and there are quite a bit more powerful ones. And still, the best way to choose a motor is to look at what other people are running, see what runs how you want to run it, and duplicate the setup. Right, well, thanks for watching. If you liked it, a thumbs up would be nice to see. And of course, if you're not already, by all means subscribe. It's free after all. Bye guys.